प्रॉब्लम है कि इशू क्या है अगर आप Azure बैठे हो 15 मिनट वो क्या रहा है एक हफ्ते में कंप्लीट करने वाले अब अगर तो ब्रेक में
I know. Can you say something? Is it talk? I'm just trying to see how the mic is capturing sound.
Or we can put the mic here. Or we can put the mic.
This is how far it comes.
That was so very nice. We're gonna do this. Then you have to figure out how to do Who's here? Latest. I would say. Yeah, it's good to be not as. Probably yeah, the development for that, but I was thinking of
probably trying to justify
it comes down to you want the whole they give you then if you think on it, it's more than that. They see that speed. 6 months. They have to maintain.
इसलिए तो तुमने मेरा डॉक्यूमेंट फॉलो किया है जो भी उसमें नया सब्सक्रिप्शन तुमने बनाया नया तुमने प्रोफाइल बनाया वो एक जो
You may wonder like why it's not the React WebAPI session. By the way, I am Gabriel. I'm just kidding. He's not coming in. So I just replaced that 3 o'clock session to this one. So now we are going to learn about Azure AutoML. It's an automated machine learning. So the agenda of the session is, first I'm going to give the overview about the machine learning, like what is machine learning and what are the different types of machine learning, and how Azure provides machine learning as a service, and how we can utilize machine learning in the Azure infrastructure. And we are going to see like a deep discussion about like how Azure machine learning service works, and what are the different components in the Azure machine learning service, and how Azure machine learning give like infrastructure for training, and how we can scale the model, those kind of details we are going to do. Then there are like a new capabilities that is introduced in the Azure machine learning service, that is called automated ML. Usually machine learning pipeline involves like training an algorithm and how we can choose the algorithm. So there are like a certain steps that is specifically to the machine learning data scientist. But the automated ML, it's a capability, so that like it's advisor kind of stuff. So it's going to suggest you like okay, for your problem, this kind of problem, you can choose the specific algorithm. This algorithm will give you like the high prediction quality of the model. So that kind of capability we are going to see. That's called AutoML, and Azure is calling that as a automated ML. And we are going to see how to build a machine learning model using automated ML in the Azure machine learning as a service, and finally a demo on how everything works too. So this is the agenda. We are going to look at that today. And I'm Shiva, working as architect in CEI, Computer Enterprise Sim. We are a consulting company and we are Microsoft partner, and I'm focusing on cloud, mobile and IoT solutions. I'm basically a Xamarin .NET developer, but I do like IoT solutions and other cloud related stuff. And you can follow me in my Twitter handle, @AC12. And also I'm live coding streamer. I do stream on like weekdays or weekend evenings. So you can follow me at Twitch itself. So in Twitch is like a live streaming stuff where we are, I'm doing like a live coding and having a discussion with you guys. So you can like, if you get a chance, you can definitely like check this out on this Twitch channel. So first we are going to see like what is machine learning. I'm going to start from like the basic stuff, like that's how I started learning this machine learning, like try to understand from the grounds. So let's start doing that one, and we will do like some experiment to understand like how machine learning works and all. Then we can see like how Azure machine learning is providing the service for stuff. So if you take a look at this machine learning, the first thing it's coming is artificial intelligence, right? Artificial intelligence is a science of getting machines to do the things what they do in the movies, like mimicking the human behavior. So machine learning is to train the machine so that like it can do the things what human can do. For example, if I need to classify the data, right? If a human thing, then I need like a lot of resources for doing that stuff. But if we train the machine to do, then the machine can do it like the scalable level. It can do like multiple classification of documents or something like that. Then it's doing that like the huge scale in that particular thing. So we are trying to train the machine so that it can do like certain tasks over there. So that's overall science. It's called artificial intelligence. And machine learning is a subset of artificial intelligence. And we are making like getting computers or machine without being explicitly programmed. So that's the difference between machine learning and the traditional programming. In traditional programming, we are having like an input and we are writing an algorithm, that's a program. Then whenever the input is passed, then the output will be generated based on the algorithm. For example, I need to add two numbers. Then I'm writing an algorithm, A plus B. Then I'm giving the input A and B, then it's giving the result back. But in the machine learning, it's a little bit different. We are not writing an algorithm, right? We are giving both input and output. We are saying like a 2,24, 2,35. We are giving lot of these kind of data like as input and output. And the machine learning model will generate its algorithm and it's giving like the accuracy of the model back. So it says like, okay, based on this data, based on this previous experience, or based on this learning, from this data, I learned that the algorithm is going to be like this. If there is a new data coming in, then it needs to retrain it again so that it can adjust its algorithm, so that it can predict the future result. So that's what like the machine learning, how that works. And deep learning is a subset of machine learning. It's learning based on a neural network. In short, like it's learning based on like how human learns, right? So it's based on like how neuron works. So the neuron gets stronger when it's doing like a repetitive task, and when it's like getting a good correlation, then neuron will get stronger, and the weak neuron points will be getting like diminished. So that's how this deep learning works in short. But there are like a vast methodology to learn like a deep learning, how deep learning works, and how we can apply the deep learning into the machine learning. But this is like the overall introduction about like what is machine learning, what is artificial intelligence. So in short, machine learning is like using a known data. So this is our data based on like a previous experience or based on like the previous data we are holding. Develop a model. Model is an algorithm. So we need to develop a model to predict the unknown data. Unknown data is like the future data that's coming into the picture. For example, like a forecasting thing, then we are like forecasting based on the previous experience. So whenever the new input is coming, then we are generating the. So in short, like machine learns the same way human do. I think I have skipped the few slides because I was a last session, so I just thought like to leave you guys earlier. I thought of like reducing my session to 30 minutes because I scheduled for 3 o'clock. But I have like a early slot, so I'm going to like show this slide. So let's do an exercise like how human learning to understand the machine learning. This might be like the starting point. There are like a lot of advanced concepts of machine learning, but I would like to always show this so that like we can correlate how human learns and whether we can apply that concept into the machine learning so that like we can understand the basic concepts. So I'm going to show you the picture. And I'm going to say this picture is called visits. Right? So how confident are you like whenever I'm showing the next picture? Are you 100% confident to predict that the new image I'm going to show? But at this point, your human brain is trained like, okay, this picture is visits, so it might be holding hand or apple or red in color. So you are having like multiple possibilities of outcome, but you are having some certain point, a learning point in your brain, so that like this picture something contains that's called visit, right? But if I'm going to show you like more pictures, I'm saying like all these pictures belong to the category called visit. Now you are like improving your previous learning, so you got like your learning point, first image, then more data is coming into that your stuff, then you are like undoing the learning and learning the new thing and try to find the correlation between all this stuff. So now if I show the next picture and if I say like whether it's visit or not,
I'll probably say yes.
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 Mm-hmm. Yeah.
because like you are finding like the common point between all those images, and let's say called red in
It's a
color,
red.
right? So this is how like the certain learning points work. So first you are trying to get like the picture. That's how like we human learn, right? So we are getting like if we are learning the new thing, we are trying to get like the overall picture and redoing it again or fine tuning more or get like more data about that one, and like our learning thing work and our perspective changes or fine tuning more into that accuracy. Right? So that kind of things only like the machine will also do. So the same way deep learning will work, but machine will do that. So we need to apply the algorithms and all. And by the way, like a visit is really red in color because it's a fictional language called Dothraki. I think GOD fans might understand that. So in Dothraki language, the fictional language, visit means red in color. Now let's see like what are the different types of machine learning. So there are like multiple types of machine learning, but I would simply like start with this one. So the first thing is supervised learning. So supervised learning is like nothing but we are saying the data set. Data set is like our data, right? So we are saying the data set, okay, this data set is belong to cat and this data is belong to dog. So we are labeling the data sets and we are feeding the data set into the machine learning model algorithm. Then the algorithm will classify the future image data sets. So if I'm showing the picture, then it can identify like whether it's dog or cat, or whether it's some other type of image, hot dog or not. Those kind of classification. That kind of learning is called supervised learning because we are giving the data set with a labeled image or labeled any data sets. And the second type of machine learning is called unsupervised learning. So we don't need to give any label. It's trying to understand the common characteristic between the data set and try to do the clustering stuff or associations between them. So those kind of training, that's called unsupervised learning. And finally, third one, reinforcement learning. So if an agent performs well, then we are giving like saying like a good job. If it's not doing well, then we are like punishing that so that it can retrain it based on the ratio of it's getting like the good one and the bad one. So that's how the reinforcement learning works. So if you take like the application of the machine learning, there are like a huge vast application. So even machine learning is not only the image classification or some other complex stuff. Machine learning is like even detecting like the fraud detection in the finance or spam detection in the emails, or you are finding like a forecasting or correlation between two or three other variables. So all these things are like machine learning, right? So there are like vast applications including like finance, I said like the fraud detection, and retail, manufacturing, media is to like classify between the different news types or something. Finance, like if you are getting a lot of documents coming in, then you can like classify between the multiple document types. For example, the loan types, the proposal types. So those are the things you can apply that in like each field. So if you think of the machine learning can fit into like any model wherever you are having the data. So the only thing is, if you have the data, then you can train the machine learning and make sure it's improving your workflow in your business units. And the image classification, that's like one fascinating stuff right now. It's coming into the picture, so that like you can detect like what type of image it is, or you can try to read the text of the OCR. Right now, I'm working like one of the projects that's like it's a mini robot. And that robot is like walking down the aisles between the grocery stores. It's going to take the picture of that store's tag and try to read the price tag of that one. So if the tag needs like a restocking or something, then it would notify the store manager so that like that tag should be restocked or something like that. So that kind of the robot we are building right now. So the machine learning models can apply in like anywhere. Any questions so far? Okay. So if you take like if you want to implement this machine learning, the normal machine learning workflow is first thing data. So we need to gather the data. So if you are like a data-centric company or data-centric client, then you would be having like a huge amount of data already in your systems. And the second thing is we need to prepare the data. Preparing data is like an important step in this machine learning workflow. The reason is we shouldn't introduce bias into the machine learning. For example, I'm having a data set that to detect like whether it's a beer or wine. Right? Then I'm taking an Excel sheet and I have all these data sets. But let's assume like the data sets is ordered in the way like the first 10 records are beer and next 10 records are wine or something. Then what it's going to do is it's going to show the bias on the machine learning stuff. Because it's continuously seeing like, okay, this is beer, this is beer, this is beer. So we need to make sure we are preparing the data so that like it's not biased into like a certain output. So we need to like sort that, random that, or whatever we need to do for the pre-processing stuff based on your business requirements. So you need to do that stuff, and also like you need to deduplicate all your records, those kind of things. So that would improve your machine learning model quality. So this step is like very important thing, like preparing the data for the machine learning models, because this is definitely going to affect the model stuff. And the third thing is choosing a model or algorithm. So we need to identify like what algorithm we need to choose for our specific business requirement. If I need to do the classification, then I need to do like a classification algorithm. If I planning to do like a regression or any other stuff, then I need to specifically choose like algorithm that solve that problem. And we need to do the training. So we have the data, and to do the training, we are writing the Python script. But to run the training, we need like a strong infrastructure. So Azure is providing that kind of infrastructure so that you can do like the cloud level training. We can see that one. Training is basically like to run the iteration on your data and identify like what model is suitable. And evaluation, so we need to evaluate and track the metrics like how the model is performing very well. And also hyperparameter tuning. Hyperparameter is nothing but like how many iteration you are running and how much duration you are running your experiment. Those kind of things are hyperparameter. So we need to make sure we are tuning the hyperparameter so that it's giving like the accurate like the prediction model. And finally the prediction, once we get into the model, we need to make sure that model and scoring script is deployed into that scalable stuff, so that like whenever we are making the prediction, then the model can like scale enough so that like it can do the prediction stuff. Yes?
On a hyperparameter tuning, is that essentially changing the percentage of the learning data that you're going to be processing?
It's not the percentage of the learning data. That also like one of the parameter, but that would not be coming into the hyperparameter. That would be coming into the training parameter. So I would explain in that way, like for example, if I'm having 100 images, right? Then if I need to train that, then what the best practice is, I need to take like at least 80% of the data say test data, and 20% of the data say validation data. So I'm saying like okay, train on these 80 images. Once you train that, then validate that model on the remaining 20 images.
Right.
So that's the default parameter for the training stuff. So the hyperparameter tuning is nothing but, okay, to train on these 80 images, I am running the model or I am running the algorithm for like 10 times, iteration of 10 times, or the algorithm running for like 100 minutes or something. So those kind of things are hyperparameter. It's basically like how many number of iteration I am running, and also like how much duration I am running, and what is the exit criteria for that.
Okay.
Exit criteria is like
a
okay,
window.
Yeah.
Okay, got it.
Exit criteria is like whether the score is going up or not, those kind of.
Okay, thank you.
Any questions? Okay, the same workflow, I put it in this way because in each workflow step we are having like a couple of questions, right? In the data pre-processing step, the default question we would be having like what pre-processing techniques should I use for my data? And for the machine learning model design and the tune model parameters, what are the different modeling techniques that are available, and what architecture can I use, and what set of hyperparameters can I use? So these are the questions that come in like every step. And if you take it into the evaluate step, how do I know my model's performance? Whether I can like versioning my model so that I can compare like the model performance with the previous versions, and how can I improve the data sets, and what metrics is so important for this machine learning model selection. So these are the different questions that's come into the data scientist mind whenever they started doing this machine learning work. And finally, like deploying what infrastructure to use to serve that model, and how to meet the latency goals. So every step we are having all this kind of infrastructure and versioning questions. So all these things is answered by the Azure machine learning service. And finally, once you deploy, if any changes happen in the data, then you need to repeat the cycle. For example, I am taking the data only with cat images. but in my scenario there is a new set of images coming in, new set of cat breeds is coming in. Then I need to retrain the data with a new set of cat images. So basically, you need to do this citation of stuff and do all these things like again in the machine learning service. So that's the biggest challenge right now in like keeping your machine learning workflow, and doing the DevOps and versioning of the machine learning models. So that's the biggest challenge right now in the machine learning workflow. That's where like the Azure Machine Learning as a service that come into the picture and providing all the answers for these kind of questions. So let's start with the Azure Machine Learning as a service. Anybody have any questions? Yes, please.
I saw in your workflow the last step being the prediction, correct? Can
Yes.
you establish a set of predictions as your data source to begin the workflow, to iterate through, based on existing predictions?
That's what
That's
supervised
data.
machine learning is all about. You provide your training data and say, okay, these are my 20 parameters, right? Which results into a specific output. And machine learning training sessions that goes through this and then builds its own algorithm. AutoML does that. As a data scientist, you might build your own model to understand that, and your test data actually validates that, and then you deploy the model for actual prediction when the actual data comes in. If that answers your question.
Does that answer your question? Or you were asking like
a little bit, but the prediction is a result set that you can compile different predictions, different scenarios, and can you loop back to those at the beginning of the workflow to reanalyze
Yeah, I
your
assume
prediction?
like you were asking, the new images are coming into the prediction, whether you can capture the new images and feed that into the training data sets.
Yes, so kind of
Yeah, it's
iterate.
based on like your application, because you are choosing like a certain training image data sets based on the previous stuff. So if you are realizing like your prediction score, whatever that new prediction is coming that's getting low, that means like your model or your prediction is like not accurate enough. The new type of data sets is coming, right? So you need to recognize that and capture that new images and feed that back into the learning system. By that way, like your model is like retrained again based on your new data sets. Does that answer the
Yeah.
question? So let's start with the Azure Machine Learning Service. So machine learning on Azure, there are like it's a spectrum of technologies. So Azure Machine Learning is giving like a spectrum of machine learning provisions. The one is the sophisticated pre-trained models. So this is where like the Azure Cognitive Service is built in. What does it mean is, if I'm having like a common problem, like I need to detect the face, or I need to read the barcode, or I need to like read the text, the OCR kind of stuff. So these are the common problems. So what Azure is doing is, they are building your pre-trained models based on their open source data or based on their huge data sets that shared between all these machine learning stuff. So what they are doing is, they have trained these pre-trained sophisticated models, and they can do like the face detection or common object recognition, OCR stuff. They provided all these as Azure Cognitive Services. So you can use like a vision, speech, language detection, all these things you can do it in that pre-trained models. And if you want to build a model for your business scenario, right? For example, I'm having a problem, but that's not fit into the common problem, common solution techniques. Then you can use popular frameworks and this machine learning service to build your custom models. So the popular framework including like a TensorFlow, Keras, Python Torch, ONNX, and also it's giving like the Azure Databricks and machine learning VMs, Azure Machine Learning as a productive services, and having like the powerful infrastructure. They are giving like a different types of infrastructure, including like a CPU, GPU, and field gateway, I think, FPGA. And they are also giving like the flexible deployment option. You can deploy that on like on-premise or on cloud. Even certain models, the compact models, you can deploy it on like the IoT edge devices itself. So you can run like the entire machine learning model in the IoT edge device, so that it can do the prediction without hitting the cloud. It can do on their own on their edge runtime. So you can train the model in like a machine learning cloud, and you can deploy that in the Azure IoT edge device so that it can do the simple device. The project I'm working on, we are doing like the similar kind of stuff. So we are deploying everything it on like some small Linux device, and that's taking the picture and running. So it has like these kind of spectrums. So in the Azure machine learning service, let's see, like we have seen already the machine learning workflow, right? So we try to fit that into the Azure machine learning service. And these icons are like a different Azure service provisions, how they are using the code. So for the prepare the data, you can use like your storage account and Azure Databricks, the Apache Spark analytics-based Databricks environment. So you can like bring your data into this stuff. And to build the model, we are using like a Python SDK that is provided by Azure. So Azure have like Azure Machine Learning SDK. So you can use like a Python script, or you can use like a Jupyter notebooks, either in your local environment, and also like Azure is providing a Azure Open Jupyter notebook. So you can use like Azure notebooks as well. So you can use that for writing your code. And once you have written your code, then you can train and test your model either local or in the remote clusters. And once you have choose your model, then you can register your model, basically like managing your model version in the model registry. So once you find like this model is good for me, then you are registering that in the model registry. It's pretty much similar like versioning control. So you are saying like, okay, my model name is some data model, and the version is 1. But based on the experiment I'm running, I need to update the model version. Then you are registering with the same name again, then it's going to create the version. That's the biggest challenge right now the data scientists having, because they don't have any like a consolidated workspace to track all their data. If something happens, if the resources like left off that company or something, then totally like their data, everything is lost, or they are tracking in like some manual stuff. But if it's working in the Azure Machine Learning service, everything is like a consolidated workspace. You can understand like what's going on, and you can go through the history, what they have run in that model, all those stuff in like one place in the cloud.
Is that like a big versioning space where you have different models over different times?
I'm saying like JIT versioning is like try to understand how the version stuff happens. It's pretty much the similar stuff, how the app versioning happens about it. So you are listing like multiple models with the versions, so that you can like navigate back and through with the versions and try to see like how that differs.
There are 2 questions. One thing is like, does it have the capability to version the data on which the model has been built?
That's based on like how you are managing the Azure Databricks. So you were saying like how we can versioning the data sets, right?
Yeah, because my model is like, if I'm trying to score my model, right? That is also based on what data has been fed on that particular run.
Yes. So
that matters for me.
Yeah, this model is like the output versioning, right? So the input data, you will prepare your data, so you can manage your data sets version in like a Databricks or the storage. So
Okay, so I have to manage that
yeah,
separately.
you have to manage that separately. That's like the machine learning service, like a consolidated solution for everything, because it has like a lot of these kind of workflows in the pipeline. So each and every step we need to make sure like we are versioning that, and we are tracking all those stuff, and we are logging that metrics in cloud.
There is one more question, like probably when you go into your demo, I can probably take a look at it.
Yeah.
Does Azure Machine Learning provide the capability of auto machine learning as well, or
Yes.
is it like I have to go and build one model, test it out? How does it work now?
It has automation. I have the demo.
Okay, we can talk about it.
I have a question on Azure Databricks.
Yes.
Is that something which allows your data to be sourced in from big data? does it have the capability to hold large data sets in it? And
Azure Databricks is like mostly it's for the streaming your data. So if you have like the big data source, then you can stream that through the Databricks and you can use that. But I don't have pretty much knowledge about the database.
Are you aware of the Spark framework?
yeah.
So if you know about Spark framework, Databricks is nothing but an abstraction on top of it.
Yeah.
So underneath that, it's all Spark, and Microsoft has partnered with this particular company, Databricks, to provide abstraction on top of it, and you have the capability to build the stuff on Jupyter Notebook and stuff like that to get the Spark deployed pretty quickly, run on Azure Data Lake and things like that, right?
So I assume Databricks is a store and Spark is a query language to query
No.
that store.
No,
No.
Databricks is not a store. Databricks is
Is
like
a
the layer
process,
that
yeah.
try to bring the store.
Oh.
It's literally Spark. Take it
Yeah.
that way, with some
It's literally
abstraction to provide details around it.
And once you like find a suitable model, then you can build a container or a image with a model and dependency, and we can deploy this container using like a web app or Kubernetes. So wherever you can do that deployment, you can do that deployment using your model and the scoring script. Then you can deploy the web service and monitor that. So first thing is we need to create a machine learning workspace. So if you want to create a machine learning workspace, go to your portal and create a resource. And if you go to the AI plus machine learning, you can select like a machine learning service workspace. And you can provide like any workspace name. I already have created. I don't want to like create more resource. But if you create that one, you would be having like a couple of resources created. For example, the Siva ML is a resource group. I'm using that for machine learning. So there are like a couple of resources. One is storage account. So this is the account you can use for like storing your data stuff. And the other resource it will be creating by default is container registry. So this is where like your container everything is deployed once you choose the model. And application insights for logging, and key vault is for secret sharing purpose, so that like your container secrets and everything will be stored using this key vault thing.
You said machine learning service workspace, right?
Yeah.
Okay.
And this is the workspace we have created here. So if you go to the workspace, there are like certain assets. Experiments, pipelines, compute, models, images, and deployments. So these are the steps we have seen in our slides. So if you first thing, you need to create an experiment here. I already have created like a bunch of experiments. Let's go to the demo experiment, which I have created yesterday night. So if you go to the experiment, you can run like a multiple runs on single experiment. Because this run is like trying to detect like different parameters to choose like the right model. Right? So I have run like 5 different runs on that. And if you go to like each run, you can have the details. For example, here I'm tracking the metrics, like the final result is 10 here. And also you can create the chart based on your run, and also the other parameters or the attributes that is available for the run is specifically mentioned. So each run is like, I'm doing an experiment, I'm running like multiple runs on that experiment. And once I'm satisfied with a specific run, then I need to register that run as a model. Then that would register the models here. And once you have registered the model, you can have like a version also. Then once you have registered the model, you can create the image from the model. So that would be creating the Azure container images. So this is the image I have created. And once you have created the image, then you can deploy that, and that deploy as a service, web service here. Then you can use that URL for doing your prediction. So this is how the steps going. So these are the different assets in the marketplace. I would show the demo that would be giving like a understanding how these things work.
Can you use the image offline, not using the portal on the URL?
Sorry, I didn't get you just.
Can the image be used as an exe, like if you wanted to work?
It's a Docker image, so you can like download that
Oh, it's a Docker.
container image. So if you go to the notebooks.azure.com, so this is where that Azure notebooks everything is deployed. So you can like run the code from the Jupyter notebooks. So they have their free cluster, so you can run all your Python code into that free cluster. So I'm going to sign in here. Let's start with the demo. So this is the Hello World demo, just to understand like how the environment works. So the first thing, this is running on the Python 3.6 environment, and this is running on like a Azure free compute cluster. So whatever you are running this code, this is going to run on like some Azure specific VMs or something like that. Or you can run like this Jupyter notebook in the local itself, but the training, everything happen in your local environment. So the first thing, the workspace experiment, all this provided by the Python Azure Machine Learning SDK. So you can import all these objects from the Azure Machine Learning code packages. And also I am importing like a couple of other Python packages also. And we need to retrieve the workspace from the config. So I have the config dot. So if you go to this folder, I have this config.json. So in this config.json, I have this subscription ID, resource group, and workspace name. So in this program, what we are doing is, I'm saying like get the workspace from the config. So I will get like the Azure Machine Learning workspace object from Python SDK. Then I can say like there are like multiple properties in the workspace. Then I can do like printing what name of the workspace it is. Then the next step is we need to create the experiment from the workspace. So for that, what I am doing is, you can see that, right, the code. So for that, what I am doing is, I am constructing the experiment variable by passing like what is the workspace and what is the name of that experiment. And once I get the experiment, I am trying to do the run on the experiment. Basically, I am trying to start logging on that experiment. That is called run. And this model is like nothing fancy. I'm just like generating a random number, but it can be like any model specific. Just to like simplify that, I'm just like creating a random number in my models. So I'm creating a random number, and that is called result. And I'm doing the logs on the run so that like it would be tracked in the metrics there. And I am creating the file. This is called my model. So this model contains random number generated. But the actual machine learning, you will be doing like a lot of TensorFlow stuff here, so that you can do like actual machine learning stuff where it's doing like a classification. But I'm like right now focusing only on the Azure machine learning as a service stuff, so I'm just like generating a random. And once you complete the run, it's going to create the run in that your workspace. And you can print like certain details from the run, including like what is the link to the Azure portal and what is the ID of that run and all. And once I choose the run, I'm selecting that run object. I'm trying to register the model, and I'm specifying like what model name it is and what model path is. So model path is nothing but like my specific algorithm or data that is exported into this model. So once I register the model, then it's going to register in the workspace here with the experiments. In the models here. So that example model I have saved as a mission magic random. So magic random having like a 2 version, and this is the data. And you can, yeah, and this is the data, and you can see like the multiple version here. You can go through like what is the value on this model and back to like what is the value of the recent version.
Do you
Back
have
to this. Yeah.
a exact model with some kind of TensorFlow or some kind of stuff?
Yes, there is, but I will show that.
Yeah, if you can just flash that now.
Yeah. And we are creating a score script. So this score script is going to do like a what is the prediction. And once that is done, then we are deploying the web service, basically like creating the container image and deploying the web service from the model. So once this is done, then you will be having your web service, and you can make the request and see like what's the system. So this is like the overall flow, like how everything works. Because that's like the complex picture, right? So when I started learning, if I bring those into the equation, then I'm like missing how Azure machine learning service works. So I'm starting from that basic stuff. The same thing, you are having like the complex image classification as well. So I'm going to this tutorial and the image classification thing. So this is the sample notebook that's coming from the Azure portal. You can take a look at that one and see like the step-by-step stuff, how everything works. If I run now, then it would be taking like much time because it's deploying the services and all. So I'm just going to show like the previous run, whatever I have. So as usual, for in this demo, what we are going to do is we are having like a image digits data set. So we are having the image of 1 to 9. This is the image classification. So whenever there is a picture of these digits coming in, then it's going to identify what number that image is. So the first thing, basically, like we are importing the Python packages, including like a NumPy, matplot library. These are like a specific math-related library to manage your data. And also we are importing like Azure Machine Learning core. This is the SDK we are managing for the Azure Machine Learning. And as usual, we need to connect to the workspace. So I'm connecting the workspace from the configuration, which is in the Siva ML workspace and what is everything. And the next thing, we need to create an experiment. So we are constructing the experiment object. The previous thing, it ran on like the local cluster, but this training is going to run on like the Azure Machine Learning compute resource. So the training itself is going to run on like the compute resource itself. So what we are going to do is we are constructing the VM size and a couple of other compute cluster parameters, and we are creating the compute target. So in this mission, all this training going to happen, and once the training done, then we are extracting the data from the compute. So that's what we are doing here, like creating the cluster for compute. And once done, then I'm downloading the data set. And this is the sample data set we are having. So each has like the digits image data sets and the actual value that's displayed there. And I'm uploading that to the cloud. The cloud is nothing but workspace default data store. So when I get the data store, it's going to be the storage account there. Any questions so far? It will be like a little bit. Okay. So once I uploaded that into the data store, which is the storage account for us, then I am training the model. This is training the local model, but you can train on the remote cluster what we have created as well. So I am creating a training script, basically that is loading the data and doing the logistic revision. So these are all the TensorFlow code where it's coming. Then I am dumping my PKL. This is the model file, so I am outputting that into the model file. Then I am registering that model file into the cluster. Sorry. Yeah, I am registering that model into the cluster. Sorry, I am going it too fast or something. And once that is done, then we are running that. I will show that. Yeah. Once we run that and get the matrix, then we are registering the model here. Similar way like how we register the model. And once the model is done, then we are deploying that model into the container and we are predicting the series. But the problem right now is we have provided the algorithm here like the logistic regression. Yeah, but we are not sure like whether the logistic regression will work or not, or whether it's providing like the high accuracy of that model or not. So that's where the Azure automated ML come into the picture. I would show these are the things we have seen already. So this is how like the Python script is. We are having the Python script and executing on the complete target, storing the run records on the experiment, and once we store that, then we are getting the run and register the model, and we are deploying that into the service. So this is the overall machine learning stuff. But the automated ML, where it's coming into the picture is, whenever we are doing the machine learning service, we need to do like manually specific the algorithm, like okay, try this algorithm and run it.
Logistics regression, for example, in your previous flow.
Yeah, try this algorithm and run in the data set, and we are getting the prediction quality. And we are trying like a different algorithm. So these steps are like iterative, and we are not sure like which algorithm will work or which model will work. So that's where like the automated machine learning comes. So we are just providing like a data set and the optimization metric and the constraints. We are saying like, okay, run for like 5 minutes, and this is my cost level for running all this training stuff. So we are providing all this input and to the automated ML. And the automated ML do all these things, try like a different algorithms and provide like the final machine learning model and the algorithm which is used for that training. So that's how the automated machine learning works. Any questions on like automated?
Are you going to show
I'm
us
going to show.
how this works?
Yes. So it's based on the Microsoft research, and they have like a collaborative filtering and no need to see the data because they are not seeing the data, they are just seeing like the values that we get for the machine. Okay, I'm going to skip a couple of slides and directly show that because this is a slide I have prepared for 90 minutes presentation. So definitely that's going to be. Okay. So for the automated machine learning, I'm going to show that demo. So the same digits data sets example. Pretty much we are importing all the packages and we are creating the experiment. But instead of providing the logistic regression, what we are doing is we are constructing the AutoML config. AutoML config is like another object that is coming from the SDK. So we are constructing the AutoML config. We are specifying like what type of task it is, whether it's a classification or regression. And also we are giving the experiment name and other metrics here, like how many iterations it should run, and what is the iteration timeout minutes, and what is the cross-validation variable. So these are the different metrics and cost and time constraints. We are providing that into the Azure Machine Learning config, and we are running that experiment by submitting this auto machine learning configuration. What it's going to do is, it's going to make like multiple iteration. For example, here I specified like it's going to be 10 iteration, right? Then it's going to run like a 10 iteration here, 0 to 9, with a different pipeline. And based on the pipeline, it's going to detect like what is the matrix and what is the score for that. And finally, it's going to choose like which is the best model or best run for that the whole experiment. So literally, like we are just saying like, okay, this is my problem. You run all your tests and give me like the best fitted model for the problem. So instead of like choosing each algorithm and try like a different algorithm, we are saying like this is my configuration and give me the algorithm which is needed for this. So once you get the best fitted or the best run or the fitted model, then you are registering that model and you are creating the scoring trace and you are doing the deployment, container images and the deployments. So finally you can test that model as well and doing like what number this image has to receive. So that's how like the automated machine learning model works, where you can configure the experiments.
So, in your constraints, right? Those constraints, whatever has been mentioned on the Jupyter notebook, those are specific to runtime parameters and things like that, right?
Yes, you need to specify like what parameters you are trying to tune for the automated machine.
Does
Basically,
it-
that's like yeah.
Does it allow us to mention some of the business constraints as well? Because
It does not allow the business constraint because this is definitely not know like what type of data you are using or what data you are using. Automated machine learning is like just observing that experiment and trying to provide like the best fitted model for you.
so the best fitted model, right, is based on the accuracy of the model, right?
It's based on the
Accuracy of the prediction.
Yeah, accuracy and score of
So that's one of the problem with automated ML as such. I mean, there are very less solution in the market who actually maximizes business benefit versus accuracy of the model. So think about in this term, right? That you say that I'm doing a prediction for insurance company.
Okay.
So you might say, I build a beautiful model and I do not pay any customer other than an actual death situation. You might be very happy as an owner of the company,
Yes.
but that may not maximize your business profit.
Yeah, in that case, right, because this is just giving like the metrics and the best fitted model is like the Azure machine learning service, it thinks like it's the best fitted model, but it's giving the metrics like what are the different type of algorithm it run. So you can choose like, okay, even if it is the best fitted model, I can choose like the model which is maximize my business. So you can see like all that metrics in the run here. I think if you go to the portal, you can run that. Yeah, I don't have it. But if you go to the portal, you can see that like those.
Yeah, because accuracy results in more submissive results at the end,
Yeah.
which may not be beneficial for business all of the time.
Yeah, you can choose like it gives a metric, so you have the power to control your stuff. Azure machine learning is providing like infrastructure and the stuff.
Does it give some kind of scoring to multiple models as well, rather than throwing out only the best model?
No, it has this is giving like individual metrics for all runs, so you can choose like whatever.
So those runs are for specific models. I mean, specific
specific algorithm.
algorithms,
Yeah.
right?
And you can use like automated ML in Power BI itself. So in the Power BI, if you have the data, then you can select the automated ML. It's still in the preview mode. I think I'm not sure whether it's in like out of the preview mode or it's in the public. So, any questions on like the automated ML stuff? It's a vast thing.
Mine's not really a question, it's just a comment. Is it projector able to be maybe
I think that's the best we can get. Yeah.
I didn't know.
Yeah. We will build a robot to identify like the focus and try to understand.
Is your slide deck going to be provided for, to a group or to?
Yes, so we will put up all the slide decks on our GitHub. It's github.com/onetug, ONETUG, OneTug. So it's Orlando.net user group. We'll solicit slides.
All right, I got GitHub, and then OneTug.
That's it.
That's it?
Yeah.
Okay.
Yeah, this is like a 90-minute session.
And then I will.
I will.
I'll put it up on. I'll also link it on the meetup page, so that way everyone gets a link.
Okay,
Yeah.
thank you.
I will try to present this in the lab. I'm working on this lab, so probably I will publish that into the GitHub repository so that you can go like a step by step, try to understand like all this.
Yeah, I got it.
And finally, thank you. And you can follow me on social medias, and please don't forget to follow on Twitch, and you can watch me live coding on Twitch as well. So, thank you.
Awesome. Thank you. Lunch is served. It's at the back of the room. So go grab a sandwich. If you don't find anything, I have some bars over here, like Kind bars and granola. So go.
Is this AutoML feature been released?
Well, but I mean, the internet's not always there. So, how, we talked a little bit with kids that with our
Are you plugged in?
No, not yet.
All right, you are ready to go live. Yep, no worries.
Some of it might go first.
You are all set whenever you. Yeah.
All right, everyone. How's it going? My name is Hunter, and today I'm teaching you, or giving you a quick guide on how to build chatbots with Azure Lewis. So, I know all of you have probably run into a chatbot at some point, but the basic premise is we have a natural language interface for getting information. You can quickly ask it questions in a hurry, and you can integrate it within a web page. You can integrate text message or voice assistants with it. A few companies did a survey at the end of 2017, Drift, Salesforce, and among others, identifying the major benefits that people identified, the reason why they would like to use a chatbot. And the main things were 24-hour service, getting an instant response, and answering simple questions. That's probably the really good niche for chatbots for business. Lewis at Azure is an API that gives you a method for pulling out specific words, like if someone were to say a number or a date, it gives you the capability of pulling out those key details out of a sentence, which is called natural language understanding, as well as natural language processing, which is categorizing text that's coming in. So what I wanted to show you guys was how to build a text message-based chatbot. So this was the system that I put together. I have you can text myself a number. It goes to a Twilio API. That passes the information along to my chatbot API, which hits Lewis, determines the intent, what you're trying to do or say, and then records that to a database to keep track of what you've said so far, the conversation history, and where you're at. And then it responds with a message back to the Twilio, the Twilio API, and sends it back to your phone. Do you have any questions?
No, that was Twilio.
Oh, what's Twilio? Oh, okay. So Twilio is a telecom API for sending messages back and forth or making calls. So when you're building one of these chatbots, the first thing you want to do is usually schedule out the conversation flow. So usually you have an issue that you want to address, and you want to categorize all those possibilities. So this is a survey for how this presentation went. And using sentiment analysis, if it's positive or a negative review, I can go down one of two different trees and dig down in more detail for more feedback. So it's hard to plan out the scope for a chatbot in general when you have a specific problem, like you want to get you want to survey a group of people. It's a lot easier to just break down exactly what you're going to say, the types of questions, which are usually one or two types of answers, and then branch out from there. When you make a call to the Lewis API, what you do is you send them a selection of text. So the query is, I want to call my HR rep, or maybe this presentation was just all right. And what it does is it sends you the top scoring intent, the score, how likely it is to be that intent, as well as if you have entities defined, something like the word call could be defined as a contact type, is pulled out of that text and fed to your API. So when you hit that API with that type of message, you can pull out information like if they want to be called, texted, if they set a date using these entities, you can pull that information out. As well as on the other side, you can see, this is the one that I built that I'm going to demo at the end, but it can give an actual sentiment analysis score. Sorry about that. It can give a sentiment analysis score. So it said this presentation was all right. It rated that as 0.23%. So out of a scale of 0 to 1, of like how positive it was 20%, which means very likely to be negative. At a 20% chance of being positive, I guess you could say.
Excuse me.
Yes.
So before you define the response, do you define the intent, set of intents, and have the machine learning train the?
Yes. So I'm going to show you exactly what this looks like. So, good question. So, the great thing about Lewis AI, which is the Azure service, is that you can create these labels, right, that you've defined in your chatbot conversation, right? If they have a positive response or negative response, what do those responses look like? If they say hello, what is that response going to look like? Goodbye. For this tree that I showed you a second ago, right, with 1, 2, 3, 4, 5 responses, I actually only needed 4 intents. It was either a hello, goodbye, or it was just a general response that I could deal with. And it's a really nice interface. When you have to build the model and you have to create the data set and all that stuff, it's a big mess coming from the data science side. So it's really nice to just have a nice user interface where you create an intent here and you define potential phrases that would lead to that. So if you want me, I'll go ahead and add one if you wanted to see it. So let's create an intent buy, right? If this was like a sales opportunity, you could have something where the person's interested in buying, and you can come up with a bunch of phrases that would map to that. So I'd like to buy this. This looks, and so on. And you just add a bunch of those so that it can properly map it to your intent. Entities are.
It can be exactly the same phrase.
No,
It does not.
it does not.
So the great thing about NLP is that instead of your normal software development process where everything is defined on true or false logic, the idea behind machine learning is that you have a statistical mapping of one thing to another. So you have a probability that one of these phrases is mapped to what you said. So let me go ahead and show you, let me remove this. And I can show you how that works. Sorry, it takes a second to build. Okay, so now I'm going to test. So we have the response. We have a couple of responses, right? But if we were to type something that isn't here at all, let's say, I thought, no, that's still very bad. Anyone have anything interesting?
And that is for hello, you're looking for?
Oh, good. No, good is on there. Great. Great is not on there.
Let's put it as, it was not that bad.
Not bad.
Not bad.
Okay.
Excellent.
So it identified correctly that out of these 4 potential intents, that it was a response with an 86%,
Positive.
confidence. Yeah.
Can you increase the font size a little bit?
Yes, I can.
Thank you.
So it picked which intent?
Oh, it picked the response
Response
intent.
intent.
So for this chatbot, which I'm actually going to let you guys try when I'm done, is simply a survey where you have a couple of different things that you can say. You can you start the conversation with hello or something of that nature. You have a response, so that it's asking you, what did you think of the presentation, right? And you can respond to that. Or if you wanted it to stop responding to you, you could say something like stop or go away, just to make sure that it's not annoying you. So for this whole conversation, we needed 3 intents. One for initiating, one for responding to questions, and then one for saying go away.
Let's try out its hard sale.
Hard?
Yeah, hard sale, SALE.
Hard sale. All right, let's see what it says. All right, it's only 37% confident because I don't have a lot of intents defined, examples defined, but it was still able to accurately predict it. I believe, so coming from a data science perspective, I believe what they're doing in the background is a bag of words algorithm, which simply does a frequency of word choice, and then it maps that using some model of their choice, probably like random forest, for mapping it to an intent. So it can handle a lot of different words that aren't defined, as well as words that are defined, and still get pretty high accuracy. But you have to define you have to provide enough examples. Otherwise, this hard sale could have passed off as some other intent. Since it only has a 37% confidence, it is right on the border. It could have been passed off as something else.
How smart is Lewis on synonyms, or you have to define all the variations of the given?
You have to define them all. Unfortunately. Do you guys have any? Feel free to ask any questions you want as you go.
But this one is actually identifying based on your text what is the intent. So if I want to create a response back, what do I do?
So that has to be handled by your API. Well, that doesn't have to be. There are many ways to do it. The way I've chosen for this project is this API in the middle. When it receives the response back from Lewis, it determines, number one, the intent, and checks the database to see where you were in the conversation along in that tree. Were you at the start? Were you at in the middle of it? Where where you're at, and then it defines the response back. You'll find that when you think about it in a broad spectrum of things, you could have any response. But when you have a tight niche problem, which almost any business will have, then you'll find that it's much easier to define exactly the scope of the conversation and what phrases would be said. Are you raising your hand?
Yeah, are there libraries that have words in it that are known regardless of how they're used as being positive or negative?
Yes. So there are a lot of sentiment models out there, and Lewis uses a pre-built one. The sentiment analysis isn't handled by you at all. That's actually handled on their end.
Okay.
So you don't actually have to define whether it's positive or negative. They have that pre-built model. You just have to define what your intent is. Basically, when you send over that message, hard sale, what do you want it to say back? Do you want to say which option category do you want it to say back?
So to create a instant chatbot, does Microsoft have already a predefined set of intents, or you just hook it up to a chatbot and you know what it's going to qualify as?
They have a template, and they have a web bot app, which has some pre-built stuff. or you can start from scratch, which is what I did. But they do have a template in place if you want to like start with something pre-built. Any other questions?
Will it do a context-based intent identification? Like, for example, okay, so this is how I started conversation. So maybe he say hello, so then I'll identify, okay, he's saying hello. And then the next one is, hey, I have a question about a movie. Then I ask, maybe my chatbot algorithm will identify, okay, he's asking a question about movie, maybe I create that, then I respond, oh, which movie? Then he say hello. Will it identify that as a movie name intent, or somebody starting a conversation, like as a hello, as a saying hello?
So I think there are two questions there. There's a two-part answer to that. The identifying a movie name is very hard. I'm not sure if it's capable of doing that. It can do dates, places, money, numbers.
No, based on a context, because I know the question I asked is what movie you want to know.
Mm-hmm.
So at that time, I can set this context as he's going to give about the movie name. Like, can I set a like maybe define an intent based on the context?
So, no, you can't. The way you have to handle it, if you created two apps, then you could, because you'd have an app specific to that intent. But the way around that is that you define it with your statuses in the conversation. So when they initialize a conversation, I track that the conversation started. So we can't start in the middle of that conversation.
Mm-hmm.
We have to start with some sort of like introducing what we're doing.
Mm-hmm.
Once that's over, then we can have more complicated things that respond exactly to what they were asking about. So if you were in a movie conversation, then when you're looking at this conversation, you'd be like in this stage already.
Mm-hmm.
So your app that sits in the middle has to track where you are and then what relevant questions you can be asking.
Can I create a more statuses, like rather than start, middle, and end? Can I have multiple statuses? Like, oh, currently our conversation status is this. Now the conversation status is different. Like, need not to be in the middle. I have 10 different statuses.
Yeah. So you actually have to build that out on your end within the chatbot API.
Okay.
The Lotus API is really just an endpoint for a natural language processing model.
Okay.
Basically, what they did was they said, we build the model for you, we'll package it up, put it in an API, because most data scientists or people in general don't know how to do one of those two or three things. So they just package that up. So your chatbot API of how you build it has to handle what to do with that intent. It simply just tells you what it mapped it to, so which is the most likely category, sentiment, and any like characteristics like money or dates. They call them entities.
In Microsoft Bot Builder SDK, they're having like a dialogues, and also you can manage your state. So using that, you can specify like different context for your conversation.
What is chat builder? Is different from this?
Bot Builder SDK that what the chatbot API is going to be. Is that right?
I'm using my own, but
Okay.
yeah, you can use that as a.
Okay, Microsoft Bot Builder is giving the SDK basically that contains like all your dialogue objects and the conversation state objects.
Oh,
So if you want to design the conversation, you can write your logic into like a multiple dialogues, and you can track the state between the dialogues and also for the entire conversation.
so that is called
Bot Builder SDK.
Then internally user
Yes, that has a set of classes and libraries that's interacting with the LUIs. So basically, your chatbot API that's built with the Bot Builder SDK, and that's interacting with the LUIs. And the Bot Builder SDK has a bot service, a big bot service that can connect with any channels, including Slack, Team, or Facebook. This is like a pretty straightforward. That's directly interacting with the LUIs.
Okay.
bot builder SDK is like a specifically designed
It is
for
one more layer.
yeah building the conversation. That's the API specific.
Cool,
And
thanks.
another thing is like whenever you are dealing with NLP, right? NLP by nature does not understand your domain concepts. So what you are asking of is like, how do I deal with a specific domain, right? So that domain context it does not understand very well naturally. So that's where your chatbot APIs comes into picture. You can implement your domain-driven design in that place and make your decision making based on your NLP output. And say, okay, I want to process it this way if the intent of the response is this, right? A movie is not that great. It might have two different contexts when two friends are speaking or when a chatbot of let's say AMC is responding to you, right? So it might have two different ways that you handle it, and that context may not be understood by Lewis, but you can make that intelligent decision on your chatbot
Okay,
API.
so my question is like maybe not exactly to that point. Okay, now consider I'm creating two different intents. Okay, so these two intents, when I give a phrase, based on that phrase, in one application box, like I don't know what is that. So now you created 4 intents as that is in a one workspace. And if I want to have a second workspace, and it should be identified as a different intent. So can a single, probably maybe the bot SDK or something might help
They
with
have
that?
another concept called dispatch. So basically, you can have multiple Lewis applications, and you can have your dispatch deployed, so that like based on your input, it can identify like what Lewis application it should be there.
What
And
is
you
dispatch? That is a service?
That's the service provided by Azure. I think yeah, that's part of the bot builder SDK. I'm not sure like whether it's coming as a service or not.
Okay.
But you can specify like a
Probably
dispatch.
that is more towards. Yeah. Okay, so if I understand, Lewis is just an API. If you give some text, you can look at it.
Exactly. Yeah. That's all it is. It's natural language processing elements for you. Yeah, that would be a much better way to handle it. You should give the presentation next time. So I handled it all on my server or my API that I set up.
Font size.
Sorry
Any
about
increase
that.
the font size,
It's a little blurry. Okay, yeah, you guys can't see that. I'm sorry. Okay. Well, anyways, so I defined that in my API that I set up. I wanted to show that to you guys, but that's not gonna work. So anyways, so I set it up within my chatbot API so that it handles those intents, and given the circumstances that it's under, how those intents map. So if you're at the, as I was saying before, if you said hello at this stage, it's not expecting a hello. It's expecting either a go away or they're responding to your question. So everything that isn't a go away is mapping to that next stage, right? So that's how I handle those multiple intents that you're talking about, because of the 4 intents, I'm only accepting 2 options, one or the other.
Can I help you understand emojis? You know,
Sorry, can you speak up?
and then understand like if they are using non-standard ASCII characters like emojis or something, or smileys, those things it can understand.
You have to define that. I'm not sure if Lewis can handle that. There are a couple packages that can. If you use Python, I would probably use a separate package if you're expecting that. Do you know one of you guys?
I don't know. It's based on like what you are.
Yes,
trying to-
like suppose if he say, hey, are you happy with the service is my question. They say instead of yes, if you put a colon and a smiley face kind of thing.
Yeah, it's based on like what you are trying to derive from that, right? Because from the NLP, it doesn't understand like whether it's a language or something. It's a machine learning, right? So it's trying to set up the characters. So you can define the synonyms. If you go to the Lewis application, you can define the synonyms on the list. So you can provide all your Unicode characters and say like this is.
So It does actually deal with emojis. Why not? You know.
Interesting.
So it actually pulled out that was a smiley face, and that had a very high sentiment. I didn't map to any of my intents, but you actually can deal with that.
That's cool.
That was a good question. Thank you.
That's just Unicode, right? I mean, you can
Yeah,
translate
that's
it.
a Unicode.
Yeah.
I didn't know. I'm glad to see that they deal with that.
Yeah.
Any other questions? That was good.
What about the different languages?
Yeah, Spanish.
It
Yeah.
can deal with that. It can deal with multiple languages.
Like
So-
if they say,
So one of the ways that I've handled that in the past is there are a lot of translate APIs. Usually what I'll do is I'll hit a translate API first, convert it to English, record what language it was in, so if it was in Spanish, all right, keep track of that, get the response from this API, and my response, and then translate it back at the end by hitting the translate API. It's an easy way to implement it, and then we were able to get 100 plus languages with just a couple lines of code. That's just another API.
Can I use Luis to identify or do a profanity filtering?
Say again?
Can I use Luis to do a profanity filtering? Say, suppose if I want to,
like
not
explicit
for
language.
a chatting purpose, like take example, my solution is if somebody is using some word which is not suitable for kids or something, can I identify, hey, this is not a profanity filtering?
I don't think Lewis handles that directly, but you could come up with an intent just full of curse words or inappropriate words.
Okay, so I need to fill.
So you'd have to add your own intent for that, and then just deal with that in your chatbot.
But it understands the negative sentiment against those words. Most of the
It needs to be a
cases.
negative.
No, need not.
But
Yeah.
but you don't want to respond to that in the normal way. You don't want to say hi when they curse you out.
Okay,
Is that what you're getting at?
so suppose I'm actually looking now is not for a chat, but take example, I'm building an application which is like a social networking application. But what I want to do is I don't want any bad content to be there. If somebody posts something, I want to use Luis not for a chatting purpose, rather whether I want to allow that post.
You can.
Azure already has this content filtering service as a separate service itself. So think about like a Louis only for detecting the natural language stuff. And once that is done, then you can pass that to the other middleware that's contacting the cognitive services, doing these kind of profanity filtering or negative filtering, those kind of things.
So that is part of.
That's part of the
cognitive.
con.
I'm pretty new to what are the services available kind of thing. So
It's interesting to see that it scored stupid on 0.455. That's real.
So 5%.
Oh, but that's negative.
Yeah.
Okay. Yeah, that's true.
So yeah, it's always on a scale of 1 to 10. So it's
Yeah.
95% confident that it is negative.
Yeah.
Is a good way to handle
Yeah.
it. If you have any other questions, feel free to keep asking. These are good questions. And once you build out that API, to connect Twilio to it, all you have to do is configure a phone number and then add the request URL where it's going to send all the responses that you get. So what Twilio does is I have a number set up. Let's see if it'll, this phone number, which you guys can actually test and try this out in a minute. And it forwards all messages to my API that I set, which is this app, and then it sends it over to my code, and then passes it along through that process. Do you guys actually want to try it? You can actually text this number. I don't know if you can see it. I'll make it a little bit bigger.
Yeah, let's try some stuff.
That's 407-676-7728.
Are we gonna get spam?
No, I won't. No, I'm gonna delete the table.
don't sell these numbers.
Yeah. No, they're gonna be deleted. I just have to keep track of them for keeping context.
See, this is interesting. We were talking about multiple languages, right? You want to see this conversation?
Sure. Oh,
do not understand the second word, right?
no.
It's actually I sent out Englishly typed positive sentiment on that, and it understood.
Interesting. Wow.
I mean, that's what I was
Okay, what did you
expecting. I said hi. It said, "What do you think of the presentation?" And I said, "Bhalo." So probably some of the Indian people out here will understand what does that mean.
Bengali?
It means, yeah, it's a Bengali word which means good.
Okay, understanding
And-
that automatically.
Yeah, and it replied that I'm glad you enjoyed it. Please let us know if we could improve.
If you add the Translate API at the end of it, then you can send it back in that language that he sent it
It
in.
did not do. I mean, most of the NLP platforms,
Mm.
they are now building their capabilities with natural language capabilities within various languages. Like, say, for example, if you see what Facebook does, right? It has a translate option, and it's like most of the languages, whatever you type in, right? It can give you the English version. So it has, most of the NLPs now has the capability.
Yeah, I said bueno in Spanish, and it
And
just
it
said,
replies
I'm
back.
glad you enjoyed it. So,
Yeah.
yeah.
But yeah, if you respond negatively or positively, it says different things.
Nice.
Yeah, and feel free to give me feedback if you like. Any other questions?
Through text.
What?
Through text.
Yeah.
You're getting your feedback right now.
Yeah, it's asking for your feedback, and then it actually gives you my contact information if you wanted to ask more questions. If you wanted to follow up with me on whatever you're building in your free time, feel free to reach out. When you guys are done, I actually wanted to measure the average sentiment given from these. So because it's stored in the database, I can actually track it. So we're getting about 75% positive, which is pretty good. And that was the sentiment that we received. So when you respond with a lot of text, it has to try to determine how confident it is that it is a positive response. So you might write enough things that it says 50% or something like that. So it's very hard to measure. But it was 75% positive, the responses. All right.
Cool.
Okay, cool.
Awesome.
Thank you very much. Awesome.
built a little map of the house, and, you know, they click on it, they